Good afternoon, everyone. Thank you for joining today's session, which is an introduction to Burp Suite. My name is Tony Torres, and I'm a security consultant with Optiv's threat management team. My goal for this session is to share what I believe are some of Burp's lesser-known capabilities and hopefully inspire you to incorporate them into your testing workflow. During this session, I'll spend the first few minutes covering the basic setup and configuration of Burp. After that, I'll give a quick rundown of what I think are Burp's commonly used capabilities before spending the majority of my time discussing and demoing some of Burp's lesser utilized functionality. One thing to note is that I'm not going to cover any groundbreaking topics, but instead I'll be directing this session to individuals who have experience using Burp but would like to learn about additional features that could improve their testing workflow. Don't worry though, there are many talks here at Zerocon that will cover some really cool in-depth research our team has performed. Last thing before getting started, make sure to join the Source Zerocon Discord channel if you haven't already done so. I've included the link to join the channel as well as my Discord username in the top right corner of my screen. Feel free to reach out to me if you have additional questions related to my talk today. So the first question I'd like to answer is, why Burp Suite? According to Verizon's 2020 Data Breach Investigations report, attacks on web apps were a part of 43% of breaches, more than double the results from last year. Unfortunately, as web applications become more robust in their capabilities to capture, process, store, and transmit data, malicious actors also stand to gain more by shifting their focus to attacking them. Additionally, we continue to see organizations taking a proactive approach to finding and resolving security bugs that may be present in their web applications. One indicator of this trend is the recent rise in popularity of bug bounty platforms and bug bounty content creators across social media. I chose to focus on Burp because I feel that securing web applications will continue to be an important part of an organization's cybersecurity program, and Burp Suite is one of, if not the most popular tool used when performing web application assessments. During today's demos, I'll be using the community edition of Burp Suite as well as a local installation of DVWA. DVWA is an intentionally vulnerable open source web application built on PHP and MySQL. It contains many types of web application security bugs and was created to be an aid for security professionals to test their skills and tools in a legal environment. I highly recommend you take a deeper look at this project if you are interested in an affordable option to learn more about web application security bugs. After starting Burp, we're presented with an option to save our project to disk. Since we're using the Community Edition, we can only create temporary projects, so we'll go ahead and click Next here. We'll then presented with the option to load configuration files that Burp should use, but we'll keep the defaults for now, so we'll go ahead and click Start Burp. It might take a while, but once it loads, you're dropped into a dashboard where you can control and monitor all of Burp's automated tasks. The first thing we want to do is configure our Burp proxy. We can do this by navigating to the Proxy tab and then the Options subtab. Here in the Proxy Listener section, we can see that we currently have a proxy running on localhost port 8080. Make sure that it is running by ensuring the checkbox is clicked here. The next thing we'll do is disable intercept by clicking this button here. After getting our Burp proxy up and running, we'll need to configure our web browser to use the proxy we just set up. I'll be using Firefox, but the configuration steps should be similar for all the major web browsers out there. I'll go into Firefox and then click this gear icon, which opens us into the options area. And then in this Find in Options, I'll type Proxy, which should return this Network Settings option. I'll click Settings and specify the option to use a manual proxy configuration. I'll specify that we should be using our localhost port 8080 as our proxy. The next thing we'll want to do is install Burp CA certificate. This is needed when testing websites that use HTTPS, as Burp needs to break the TLS connection between your browser and target web server in order to intercept the traffic. By installing Burp CA certificate as a trusted root in your browser's trust store, Burp is able to create and sign a TLS certificate for each host you visit. This allows you to browse and test HTTPS URLs as normal. You can export Burp CA certificate from within Burp, but I find it easier to download the CA cert by browsing to Burp in the web browser we just configured. This can be done by navigating to http burp, clicking this CA certificate and saving the file. We can verify that it has been saved by going into our downloads file, and we can see it here. We'll then go back into our options tab, and this time type certificate and the option to view certificates. From this certificate manager prompt, we can then import the certificate we just downloaded. We'll enable the options to trust the certificate to identify both websites and email users and click OK, and then click OK again. If everything was successful, we can now navigate to websites that use HTTPS, and we'll be able to start seeing some traffic being intercepted. This last step is optional and probably not needed for most cases, but I'll be modifying a configuration setting in Firefox to allow Burp to capture the traffic between DVWA and Firefox. This setting is found in Firefox Configuration Editor, which is accessed by navigating to About Config in the URL bar. We can go ahead and accept the risk and continue, and then search for the preference by typing in network.proxy.allow hijacking localhost and click the option to set it to true. We can now browse to DVWA in our web browser to see whether this configuration change allows us to capture traffic on our localhost. We can see here in Burp that we are capturing traffic from our localhost interface. Now that we have our infrastructure set up, I want to briefly cover some of Burp's well-known functionality before getting to some of its lesser utilized capabilities. You can configure your target scope by browsing to the Target tab and then clicking the Scope tab as shown here. By default, nothing is in scope, but here is where you can add specific URLs to be included or excluded as necessary. Additionally, you can enable this advanced scope control to define rules for each part of the URL component as seen here. This can be useful in many different scenarios. For example, if you know your target has many subdomains that are in scope for testing, you can add an entry only for the main domain versus having to add an entry for each subdomain. We'll add our localhost to scope by entering localhost in the host or IP range field and then clicking OK. When you first add an item to scope, you'll be asked whether you would like to stop sending out-of-scope items to the history or other Burp tools. We'll click Yes for now. Now that we've added our localhost to scope, we can clean up our Burp history by going into Proxy and HTTP history and then selecting all of the entries and deleting the selected items. The Proxy tab is where all traffic interception related capabilities are found. Here you can intercept and modify web requests on the fly through the Intercept tab. You can browse your full history of requests and responses in the HTTP history and WebSocket history tabs, and you can configure the proxy settings in the Options tab as we did earlier. The Intruder tab allows us to automate sending web requests as part of many different tasks performed during testing. This may include things like password guessing attacks, content discovery, or fuzzing. One thing to note is that Intruder provides many different attack types to accommodate various types of tasks. The most common attack type used in Intruder is Sniper, which is selected by default. This attack takes a single list of payloads and targets each specified payload marker individually. I'll cover the remaining attack types in the next section, but for now know that Intruder is used when you'd like to send many requests to the target for the purpose of analyzing response behavior. Finally, the Repeater tab allows us to manually modify and resend individual HTTP and WebSocket messages while also keeping a history of past request and response pairs. Repeater is most useful for targeted testing when you believe you may have found a bug and want to manually modify content to observe the response. With the quick setup and common capabilities out of the way, we can now dig into some of Burp's underutilized functionality. The first thing I want to cover is the use of hotkeys. The hotkeys I tend to use the most when testing include toggling proxy interception or Control-T, sending requests to Intruder and Repeater with Control-I or Control-D respectively, and switching to the dashboard, target, proxy, intruder, or repeater tabs with Control-Shift-D, Control-Shift-T, Control-Shift-P, Control-Shift-I, or Control-Shift-R respectively. There are additional hotkeys enabled by default and many more that can be configured within the User Options Miscellaneous tab. Here we can edit the hotkeys to configure them as we see fit. The next feature I want to discuss is the ability to specify what types of requests you'd like Proxy Intercept to trigger on. This is configured within Proxy's Intercept Client Request section of the Options tab, and is useful if you have specific conditions that you're interested in. For example, if you only wanted to focus on authenticated related requests, you might add an entry to only intercept post methods. We can do that by adding a rule that matches on the HTTP method and matches the post keyword. In this scenario, all HTTP requests that don't match pre-existing conditions would not be stopped in the Intercept tab. Additionally, this functionality can be configured for HTTP responses in this section here. We'll then turn Intercept back on to see whether our newly configured rule is working correctly. We'll reload our DBWA page, which should issue a GET request and see that it loads successfully. We can then do a login attempt, which should issue a POST request and see that the request is now being captured in Intercept. Let's turn Intercept back off for now and go back into the Options tab. If we scroll down, we come across a section where we can automatically modify responses. This is useful when you'd like to remove any additional front-end functionality that may not be of interest to us when testing. For example, Burp can strip client-side protections, including hidden or disabled form fields, input validation checks, and other controls that we'd like to test for. I won't cover each option in detail as they're pretty self-explanatory, but I still wanted to highlight them in case someone was unaware of this functionality. If we reload our page in the browser, we'll see some additional fields that weren't present to us before. The next thing I want to discuss is Burp's Match and Replace. This takes a regex string as input and automatically replaces parts of proxy requests and responses that match the specified regex rule. There are many ways this feature can be utilized, and Burp comes configured with predefined rules such as modifying user agents and disabling certain protections. Additional match and replace examples could include changing all instances of true to false in the request body or parameter values and vice versa. Similarly, another rule can replace known user strings with the value of admin to test whether this causes the application to expose additional functionality. The final proxy option setting we'll take a look at is Tls Passthrough. I'm not going to cover any specific demos, but this feature allows you to specify host or ports that Burp should not proxy traffic for. When testing a web application with Burp, it's not uncommon to encounter unexpected errors on certain hosts that prevent the page from loading correctly. There may be many reasons for this, but Tls Passthrough may be a possible workaround if you're unable to identify what's causing the issue. The next two things I want to discuss are small features available in Repeater that can save you a lot of time if you find yourself using Repeater fairly often. We'll send a previously captured request to Repeater by selecting one from our History tab and then using our hotkey of Control-R to send it over. You can see that the Repeater tab briefly blinks, indicating that the request was sent over successfully. We'll switch over to the Repeater tab with our Control-Shift-R hotkey, and here we can see the request. One small side note, you can rename the individual request tabs in Repeater and Intruder by double-clicking on them. This can be useful if you find yourself sending many requests to either Intruder or Repeater. There may be times where you find yourself wanting to convert the HTTP method of a request you have in Intruder. Burp allows you to easily convert between GET and POST request by right-clicking the desired request and selecting the option to change request method as seen here. We can see that when we click that option, our GET request was converted into a POST request. We can then click Send and see that we get a 200 OK response. If we right-click and change the request method back, and re-hit send, we also get a 200 OK response. This may be useful if you're running into some controls that appear to be filtering content. One common trick to bypass filtering involves changing a request method to verify whether the malicious value will be prevented when sent in the message body instead of the query string, and vice versa. Other times, you may run into situations where you have found an entry point into an application, but your payload contains binary data. You can easily change the body encoding from the standard URL encoded format to multi-part encoded and vice versa by clicking on the Change Body Encoding option as shown here. I'm going to spend the next few minutes focusing on Burp's macro and session handling capabilities, which are probably the two most useful features I'll discuss today. If you've ever tested a web application configured with session handling or state protections in place, you've probably realized how annoying they can be when trying to automate parts of your workflow. This is where Burp session handling rules can really shine. The idea of Burp session handling rules is pretty straightforward. A user can define custom rules which specify certain actions Burp will perform on outgoing requests that match criteria defined in the rule. The actions performed may include modifying cookies in the request, checking if the session is still valid, or running a user-defined macro. Don't worry if this all sounds overly complex. We're about to configure a session handling rule that will allow us to password spray a login portal which employs CSRF tokens. We'll first browse to the DVWA login page in our browser and make sure that traffic is still being captured in Burp. I'll refresh the login page and then navigate over to the Proxy tab with our hotkey of Control-Shift-P and can confirm that traffic is indeed still being intercepted. Jumping back into our browser, we'll attempt to authenticate to the page with the credentials of admin and see that we received a login failed message in our browser. Within Burp, we can look for the login request that was sent, and we notice that DVWA actually responded with a 302 message. The next response actually contains the login failed message that we received in the web browser. We'll send the initial authentication attempt over to Intruder with our Control-I hotkey and then navigate to Intruder with Control-Shift-I. We'll select the Positions tab where we can specify our attack type and payload markers. We want to perform a password spray using the username admin, so we'll use the default sniper attack that's enabled here, and we'll clear out the payload markers. We'll then enable a single payload marker to be set on the password field by highlighting the value and then clicking the Add button as shown here. We can then add some commonly used passwords that should be performed as part of our intruder attack by navigating to the Payloads tab and then manually entering values here. I'll add the values DVWA and password for now. The last thing we need to do before we can start our intruder attack is configure Intruder to follow redirections, since we notice DVWA responds to login request with the 302 message. This can be done by finding the Redirections section at the bottom of the Options tab and selecting In Scope Only. With everything configured, we can now launch our intruder attack. We'll navigate back to the Target tab and click on Start Attack. This is just a warning saying that the Community Edition will throttle traffic. We can just click OK for now. Within the results, we'll see two sets of request-response pairs for each login attempt. This corresponds to the redirection that's performed as part of our login attempt. Viewing the second response, we can see that instead of a login failed message, we actually receive a CSRF token is incorrect message. In order to be able to successfully automate this attack, we can utilize Burp's session handling capabilities. We'll first close out the results of our intruder attack and then navigate to the Project Options Sessions tab. In order to perform an intruder attack against DVWA's login page, we need to obtain a valid CSRF token and then submit that token as part of our login request. We'll create a new macro which will automate this process for us. Within the macros section of the Sessions tab, we'll want to click Add, which results in a macro editor and macro recorder window being brought up. From within the macro recorder, we'll want to select the request that results in us obtaining the CSRF token. I know from previous testing that the request is the GET request that comes before the login attempt. We can confirm that by searching for the user token value and seeing that the server responds with this value, which represents the CSRF token. We'll click OK, and then we can test our macro by clicking here to see that the token we received, in this case it's 9B195, we can test it again just to confirm that the value changes with each subsequent request, which it does. Perfect. We can then rename our macro. In my case, I'll rename the macro to get user token and then click OK. Now that we've modified the process of obtaining a new CSRF token via our macro, we'll proceed to add a session handling rule which Burp will use to perform specific actions when making HTTP requests. We'll do this by clicking the Add button on the session handling rules and then rename our rule to the attempt login. We'll add a rule action of running a macro and then select the macro that we just created. We can then press OK and add the scope, which again we can use the advanced scope control, and we'll limit this to be local host. And then we can exit out of this. And now we see that our session handling rule for attempting to log in has been added. We can navigate back to our Intruder tab with Control-Shift-I, go back into the Positions tab and make sure that this is the correct request that we want to perform an intruder attack on, and then we can rerun our attack. This time we see that the second response responded with a login failed message and not a CSRF token is invalid message. And we also notice that the request with the password of password actually resulted in a successful login. So we were able to perform a password guessing attack against DVWA using a session handling rule and intruder sniper attack. But what if we wanted to leverage Intruder to automate testing of some other type of functionality? This is where we could leverage Intruder's other attack types. Intruder provides 3 additional attack types, which are Battering Ram, Pitchfork, and Cluster Bomb. It is easier to understand each attack type through a hands-on example, so we'll perform each attack type and then discuss what is happening. Because the goal of this demo is to understand how each intruder attack type works, we'll be performing the attacks against the same login form we tested earlier. Before diving into the other attack types, let's run another intruder attack using Sniper, but this time we'll also add a payload marker to the username field. Again, we can do this by highlighting the value supplied in the username and then clicking the Add button. Before running another intruder attack, let's review what payloads we're supplying. In this case, we're using the values of DVWA and password to be sent in our attack. We can launch the attack, and we notice that our initial request is the control group containing the original values supplied, which in our case would be admin. The first round of requests, we can see that the DVWA payload was added to the username. The second one, we can see that the password payload was added to the username. And then the next 2 ones, we can see that DVWA was substituted for the password values. So essentially what's happening here is that Sniper will add the payload to 1 marker at a time until a request has been sent for every payload at each marker position specified. This means that the total number of requests sent will be the total number of payloads multiplied by the total number of payload marker positions specified. The next attack type we'll look at is Battering Ram. We can close the results of our intruder attack, go back into the Positions tab, and select the option of Battering Ram. Battering Ram also uses a single set of payloads, which is defined here, similar to Sniper, but instead it will add the payload to all specified markers at once. So when we launch our attack, we can see that we only had 2 requests that were sent, and we notice that it updated the username and password values with the payload specified. This means that the total number of requests sent per attack will be equal to the total number of payloads provided in the attack. The third attack type we'll look at is Pitchfork. Pitchfork differs from Sniper and Battering Ram in that a payload set is defined for every payload marker position specified. So in our case, we see that we have 2 markers specified, and so we have 2 payload sets that need to be defined. We can go ahead and define the payloads that should be sent as a part of payload set 2. In our case, we'll use Optiv and Firefox as the 2 payloads just to help us differentiate when we're looking at the results. We can launch the attack and note that Pitchfork only sends 2 requests as a part of this attack. This is similar to Battering Ram in that the amount of requests sent will be equal to the total number of payloads specified in each payload list. The difference here is that we can see for payload set 1, which contained the values of DVWA and password, those values were only applied to the username field, whereas the payload specified in payload set 2, which were Optiv and Firefox, those were only applied to the password field as shown below. The final attack type we'll look at is Cluster Bomb. Cluster Bomb is similar to Pitchfork in that a payload set is specified for every payload marker that is defined. But as the name implied, Cluster Bomb will try every possible combination of payloads. When we launch the attack, we see that there were a total of 4 requests that were sent. This is because the total number of requests sent as part of this type of attack will be equal to the total number of payloads multiplied by the total number of payload sets provided. So we're right at the end of my 30 minutes that I have today. I hope you've been able to learn some new things from this session and are able to implement some of this functionality in your testing workflow. Thank you again for joining me, and I'll open it up to any questions you all may have.